Here are notes for section 9.4, solving equations factored form. So up to this point, we've multiplied binomials, and we've showed some shortcuts in section 9.3. And today we're going to kind of start to put everything we've done together into solving some new things we haven't seen before. So we'll start with finding greatest common factor. So greatest common factor, the largest number that goes into both of these. Note that 12 goes into 12 by multiplication. So 12 multiplies with 1 to go into 12. 12 multiplies with 4 to get to 48. The largest number that goes into both of those is 12. Between 18 and 42, I like to look at factors of the smaller number and see if they go into the bigger one. So like 2 goes into both. 3 goes into both. The next one is 6, goes into both. The next largest number that goes into 18 is 9. 9 does not go into 42. And then the next largest number is 18, and 18 does not go into 42. So the biggest number on our list was 6. Okay, we're going to do two things in this section. We're going to use this property to help us solve these kind of funny-looking equations. And then we're going to use this idea of greatest common factor that we did in the warm-up to help us rewrite equations into this form and then be able to eventually solve them. And the process for unmultiplying, we call factoring, is what we're going to focus on the rest of this unit. So anyways, the zero product property. Zero product means multiply. So this property is telling us that something about what happens if you multiply any two numbers and their answer is 0. What if this is the case? So if you multiply any two numbers and they're equal 0, then what more did you know? Well, then we know that either or both A equals 0 or B equals 0. So what is this? So what's this? And hopefully this is rather intuitive. That you can't multiply two non-zero numbers and get 0, at least in our number system. So how is that useful? Well, it's useful if we have these things called binomials. If we're trying to multiply two of these like binomials together. So what this is really telling me is that I have two numbers. This is a number and that's a number, and they're multiplied together, and their answer is 0. So what this property tells us is that either the first group had to have been 0, or maybe the second group was 0. Well, how do you solve these? Well, this is like math you've been doing likely since 7th grade. These are one-step equations we did at the beginning of this year. How do you solve a one-step equation? Well, undo addition, undo subtraction, and voila. Look at that, 2 answers. Okay, that all came from this property that said since I had two things multiplied together and their answer was 0, then one of them had to have been 0. So what x's make that happen? And we do that by solving the one or two-step equations you get. Okay, we'll try it again. Here's two things multiplied together, and their answer is 0. So what made the first group 0? Well, we can do that by just writing a one-step equation. X plus 3, maybe that was 0. Or maybe x minus 5 equals 0. Well, minus 3 from both sides. One answer is x is negative 3. How about add 5 to both sides? Maybe another answer is 5. The other skill we're going to have to use is factoring. Factor is the same as unmultiplying. So we're going to figure out what numbers, what had to multiply together to get these things as answers. So to do that, we'll figure out what's the biggest number that goes into each of these things. So what's the largest number that goes into both 8x and 12y? Well, what's the biggest number that goes into both 8 and 12? And that answer is 4. Are there any variables shared? No. So now we'll put some parentheses and we'll say, well, what times 4 gave this as an answer? Well, 2x times 4 gave 8x as an answer. And what times 4 gave that 12y as an answer? Well, you need to multiply it by 3y. And note, we've created a distributive property problem by figuring out what had to go in. This was the biggest thing in common, and what do you have to multiply this by to get this as an answer? 2x plus 3y. We play the game again. What's the biggest number that goes into 14y squared and 21y evenly? We'll see the largest coefficient that goes in is 7. Note that there's a y squared and a y. So y goes into each of these as well, because they share at most one y. So we'll say to ourselves, what did 7y multiply to make this stuff as an answer? We'll go from 7y to 14y squared, get it multiplied by 2 to go 2 times 7 is 14. And we also need a y, because y times y is y squared. Okay, playing that game again, what times 7y is 21y? 3. Similar game, 14m plus 35n. I think 7's in common again. And there's no variables in common, so they're not the same. So 7 times what's 14m? It's 2m. 7 times what's 35n? 5n. Okay, we're going to put it all together and now use these two skills to solve some problems. So note that we've got some things multiplied together. So we've got some weird squared terms that we haven't really ever had to solve before. A strategy for solving this is called factoring. So we're going to try to figure out what had to multiply together to give this as an answer. And then we'll solve, once we have two things multiplied together and they equal 0, then we'll do what we did at the beginning, use that zero product property to solve. So first, we're going to factor. So is there anything common between a squared and 5a? Hopefully we notice that a is in common. Well, what times a gave this as an answer? A times a is a squared. A times 5 is 5a. Okay. Step 2 is now we'll use zero product property. So that means since this is two things multiplied together, maybe this was what made it 0. Or maybe this is what made my polynomial 0. Well, this is pretty easy. It's already solved. And we'll solve this one-step equation by subtracting 5. Boom, 2 answers. Same game. Let's find we got to solve something with a squared in it and another x. We haven't really seen how to do this. One strategy is factor, so let's find what's in common. Between 3x squared and 18x, 3 goes into both, and x goes into both. So, what times 3x is 3x squared and x? What times 3x is 18x? So 6. So now we'll say what could have made that equals 0. Or maybe what made that 0. We'll divide by 3. X had to have been 0. Subtract 6. X could have been negative 6. I'll leave these two for you to do on your own. What if they're not? What if I have something that looks similar but not equal to 0? Well, let's get it into that form. I want the quadratic or the thing that's squared. I want that thing to be positive, so I'll subtract the other thing. So I get this equation. 2x squared minus 4x is 0. Okay, I have an equation with an x squared and x. Let's try to factor. So let's find something in common. I think 2 and x goes into everything. We need an x to multiply up with to get 2x squared. I think just a 2 here. To get 4x times negative 2 is negative 4x. Okay, maybe this was 0. Maybe this was 0. Divided by 2, x had to have been 0 over here. Or maybe I add 2, and x could have been positive 2 for my two possible answers. So one more time, subtract 14s from both sides, and get 4s squared minus 14s is 0. Anything in common? Absolutely. Let's see. I think the biggest number that goes into 4 and 14 is 2. And there's also an s in common. What times 2s is 4s squared? 2s. What times 2s is 14s? I think that's a negative 7. So my two equations are 2s could be 0, or 2s minus 7 could be 0. So divided by 2, s is 0. This looks like a two-step equation, so I'll add 7. I get 2s equals 7. Divided by 2. S could have been 7 over 2. If the decimal is 3/2. So after the zero product property, it's just solving a couple equations using solving like 1-2-step equations that you've been practicing since about 7th grade. It's the factoring that takes a little bit of practice. But look over take a second look at these. Check out the answer. Check out these 4 extra ones I left for you to work on your own. And if you have questions, come talk to me in class.